G. Gate valves, tapping valves, and tapping sleeves. 1. Gate valves. The design, component materials, construction, manufacture and testing of all gate valves of nominal sizes 4 inches and larger shall conform to AWWA standard C509-01 or latest revision thereof, for resilient seated gate valves for water supply service. All bronze used shall be a high-strength yellow brass alloy comparable to copper alloy number 867, ASTM designation B584. Valves are of the disc type with non-rising stems and parallel seats. Valves are designated for installation in either a horizontal or vertical position and for mounting on a horizontal pipe, unless specified otherwise. All mechanical joint valves are supplied with glands, bolts, and gaskets. Bolts for mechanical joints are ASTM A536 specially alloyed and heat-treated ductile iron conforming to ANSI/AWWA standard C111/A2111, or B high-strength, low alloy steel conforming to AWWA standard C111. All valves shall be class 150 and open right, clockwise, unless otherwise specified on the plans. Valves on recycle water mains shall open left, counterclockwise. Valve ends shall be either flanged, mechanical joint, hub end, push-on joint, ring-tight, or any combination thereof. Stuffing boxes shall be of the O-ring type. Gear cases shall be of the total enclosed type of such a design to enclose the gears, the stuffing box, and the valve stem. 2. Tapping valves and tapping sleeves. Tapping sleeves shall be mechanical joint type. Tapping valves shall be mechanical joint type conforming to the requirements of the preceding section. Tapping valves and sleeves shall be furnished with glands, bolts, and gaskets. Tapping sleeves made of steel are to have a coat of baked-on vinyl coating, or epoxy coated. In place of this, tapping sleeves may be manufactured of stainless steel. All bolts shall be high-strength low alloy steel meeting requirements of AWWA standard C111H. Butterfly valves. The design, component materials, construction, manufacture and testing of all butterfly valves of nominal sizes 20 inches and larger shall conform to AWWA standard C5044 rubber-seated butterfly valves. Valves shall be class 150B of the short body type with a 150 psi bidirectional shut-off rating, a 300 psi hydrostatic body shell test and a line velocity of 16 feet per second. Valves shall be for mounting on a horizontal pipe with a wrenchnet on top. Valves are for buried service, unless otherwise noted. All valves are to open right, clockwise, unless otherwise specified on the plans. Valve body shall be of cast iron conforming to ASTM designation A126, Class B. Valve shall be of such design that the discs will seat at 90 degrees with pipe axis. Valve body ends shall be flat-faced flanged with facing and drilling in accordance with ANSI B16-1, Class 125. All valves are to conform to AWWA C504, Table 2, laying length for flanged valves and minimum body shell thickness for all body types. Valve disc shall be of cast iron A48, cast iron A126, Class B or ductile iron ASTM A536, grade 65-45-12, and shall be of disc design to provide 360 degrees uninterrupted seating. The valve seat shall be natural or synthetic rubber and may be applied to the disc or body. For valves 24 inches or larger, the rubber seat shall be capable of mechanical adjustment in the field and shall be field replaceable without the need for special tools. Mechanical adjustment or attachment of the seat and seat ring does not include welding. The mating seat surface shall be type 304 or type 316 stainless steel, Nichrome, or Monel. Sprayed or plated mating seat surfaces are not acceptable. Valve shafts shall be type 304 stainless steel conforming to ASTM A276 and are to have a diameter equal to or greater than that shown for Class 150B in Table 3 of AWWA C504. Shafts are to conform to the requirements of Section 3.3, Valve shaft of AWWA C504 for one-piece or stub shaft types. Connection between the shaft and disc is dowel or taper pins, if used, which are mechanically secured. The valve assembly shall be furnished with a factory set, non-adjustable disc shaft thrust bearing which maintains that the valve disc is centered within the valve body seat at all times. Valve shaft bearing shall be permanent, self-lubricated, bearings which provide continuous, low-friction maintenance-free operation. Shaft bearing shall be contained in integral hubs of the valve body. Valve shaft seal shall consist of O-rings of VV type, or O-cup type ring packing where the shaft projects through the valve body for the actuator connection. The valve shall be provided with a fully enclosed, permanently lubricated actuator of the traveling nut or worm gear design. The operator shall be designed such that constant input speed results in variable output speed with slowing down valve closure at the ends of travel. The effect shall maintain the rated output torque throughout the entire travel. The actuator shall be connected to the valve shaft by means of a key and keyway connection. All actuators are to have adjustable, mechanical stop limits in accordance with C504 Section 382. All valve actuators shall be capable of withstanding 450 feet lb of input torque against the open or closed stops without damage. Valves for above-ground applications shall be provided with a hand wheel. The hand wheel shall have an arrow thereon, indicating the direction of the opening. The hand wheel shall be suitably fastened to the actuator input shaft. Actuators equipped with hand wheels shall be designed to produce the specified torque with a maximum pull of 80 pounds. Of the hand wheel rim. The requirement for either wrenchnet or hand wheel shall be specified on the plans. The number of turns to open, close, the valve shall be consistent for each valve size for the manufacturer and shall be approved. All interior wetted ferrous surfaces of the valve, including the disc, shall be coated with epoxy. The epoxy shall have a nominal thickness of 10 mils, and shall be in accordance with AWWA C550. Valves for below-ground applications shall be provided with an AWWA wrenchnet. The wrenchnet shall have an arrow cast thereon indicating the direction of opening. The wrenchnet shall be suitably fastened to the actuator input shaft. If the shaft is splined, the operating nut shall be formed to fit the splined shaft. If the shaft is smooth, the operating nut shall be fastened to the input shaft by means of a 5/16 inches diameter steel pin passing entirely through the shaft. Key with keyway shall be acceptable. If the shaft is splined, the wrenchnet shall be formed to fit the splined shaft. The actuator shall be designed to produce the specified torque with a maximum input of 150 feet lb. Applied to the wrenchnet. I. Valve boxes. All valve box assemblies are to conform to the details shown on the plans. Each valve box assembly shall be of cast iron and shall consist of a base, top section, and lid. Valve boxes shall be of a single size with a nominal diameter of 6 inches. The valve box lid shall be labeled water and is so designed so that it will remain firmly seated in place when subjected to vehicular traffic. The valve box assembly shall be of sufficient toughness and strength to withstand impact loads and shock resulting from vehicular traffic. The valve box assembly shall be coated with a standard bituminous coating of either coal tar or asphalt base applied to all inside and outside surfaces. The valve box lids for valves on recycle water mains shall be square covers and labeled recycle water. J. Meter boxes. All 5/8 inches through 2 inches meters and 2 inches air release valves shall be housed in metal boxes as specified herein as shown on the plans. For non-traffic bearing locations, the meter box assembly for 5/8 inches through 2 inches meters shall be cast iron and shall consist of oval and rectangular box as shown on the plans. For traffic bearing locations, the meter box assembly for 5/8 inches through 2 in. meters shall consist of a cast iron rectangular box and a steel checkered plat rectangular with raised lug pattern as shown on the plans. The castings shall be dipped in coal tar at a temperature of 350 F and the metal shall be at a temperature of 300 F prior to dipping. The casting shall be dipped and cured independently, and the coating shall have ceased to be tacky within 72 hours after dipping. The steel checkered plate rectangular cover shall be hot dip galvanized after fabrication. The meter box shall have an ultimate tensile strength of 25,000 psi and is not to be brittle. The casting shall have an as cast clean smooth surface and be free from internal porosity. Castings that are made smooth by grinding are unacceptable.